Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by Didik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Okay, Bismillahirrahmanirrahim. Assalamualaikum, good evening and hi to all the teachers, parents and the wonderful students. So welcome to Pusat Tuisyen Academy YouTuber, a joint venture with Didik Malaysia and Kelab Guru Malaysia with the hashtag bermula percuma and selamanya percuma. So before we proceed, let's begin our session with the recitation of Kitab Al-Fatihah, and for the non-Muslim, please take a moment of silence. Okay, how is everyone doing today? So my prayer is that everyone is in the best of health and ready to proceed with today's class. So let me introduce myself. I am Madam Rosmaya from SMJK Yuhua Kajang Selangor. So today I will present alone because my partner, Madam Non, cannot join us today. So before we start our discussion, please subscribe to my channel so that you won't miss any of my new video in the future. As usual, the lesson will last approximately for 1 hour, and the certificate link and the credit claim link will be given at the end of this session. So you can only use EDD email and more email to claim the certificate. So I will, I put already in the chat box, okay, the link to apply the EDD email, okay. And so be sure to follow the class up until the end and give your full cooperation in making this lesson a lively one. Okay. So I would also like to remind students to use appropriate language and also use appropriate profile picture. If possible, use your own picture if you wish to post comments in the chat box. So I'm pretty sure all of the students here are excellent students who will uphold a positive classroom environment. So stay focused, and if you have any questions, so you can write in the chat box. So without further ado, okay, I will announce the first letter and together with the 2-digit codes for the credit claim. Okay, so the code is letter A, okay, letter A, and the digits, okay, 24, or 24, okay, 2 and then 4. Okay, so now I'm going to open my slide. Okay, so let me introduce the pre-U teams that we have in Academy YouTuber. Okay, so this I'm the leader, okay, of the physics pre-U team. Okay, in our team we have Teacher Su, Teacher Hapsayu, and also Teacher Non. And the next team is biology team led by Cikgu Faiza. And chemistry PU team led by Cikgu Shahnun. And mathematics team led by Teacher Im. And perakaunan and economy PU led by Madam Fizi. Okay, so we also in Academy YouTuber we also have apps. So our physics video also you can get in there. Okay, there are many videos there, not just physics. So a lot more you can refer to the apps. Download the apps from the Google Play Store. Okay, so so now we have come to the main objective, okay, for today's live. Okay, today's live tuition class, we are going to do some revision on topics quantum physics and nuclear physics. Okay, so we are going to solve a few questions. Okay, I chose the question and put it in the link, PDF link, and it's in the description part below, the YouTube video channel here. And I also posted in the chat box the link, so you can get from there, those who haven't. Okay, so those who've done the question can also put your answer in the chat box, okay, as we discuss the question together. Okay, so let's go to question 1. Okay, we read the question first. Okay, question 1. A graph of photocurrent I against the applied potential difference V in a photoelectric experiment is shown below. Okay, so I against V. Okay, the cathode is illuminated by a monochromatic light of frequency F. So determine the maximum kinetic energy of the photoelectrons emitted. Okay, second question. If the work function of the cathode is 1.02 electron volt, so determine the frequency F of the light used. Okay, question 3. If only 20% of the incident photons emit photoelectrons, so determine the power of the incident light. Okay, so before we do the question, okay, you need to understand the graph. Understand the graph. So how you get this graph? Okay, let's do some revision how you get the graph. Okay, so refer to the diagram here. So this is evacuated glass tube. Okay, so when the photon is incident to the plate here, there are two metal plates. Okay, what happened? The metal plate, the electron we call photoelectron is released from the metal. Okay, some of the energetic electron, okay, will move towards the other metal plates here. So if we connect to a circuit, make a complete circuit, and we put a emitter here, okay, micro emitter in this case. So what happened? You can see there is current flow, even though there is no battery or cell put in the circuit here. Okay, because of the electron. Okay, the energy, some of the energetic electron can flow through the circuit here. So that's why the graph here starting at 0 volt, the current still shown by the emitter. But when we put a cell here, okay, any power or a power supply here, where the terminal positive is put on this side, so that this metal plate will be positively charged, so the electron will attract to the metal plate here, so it will accelerated and more electron can flow throughout the circuit here. So the emitter will show reading, increase in reading. So that's why we get the graph. Okay, increase here, increasing the current, and we can increase the voltage here. Okay, so that more and more electron, okay, can accelerate it towards the other plate and complete the circuit, and the emitter reading, okay, will show increase in current. Okay, and until at some until it reach the threshold frequency, so there will be no more electron released from the metal, and the current become constant. Okay, remember that current is a flow of charge, the flow of electron, rate of flow of electron. So it comes to maximum already. And what about the negative side here? Okay, so this is the voltmeter. Okay, to show to get the reading lah, the reading from emitter and the voltmeter here to plot the graph. Okay, when we reverse the terminal of the battery, okay, this is the negative part, where the V, the voltage, is negative reading. Okay, so when we reverse the terminal of the battery, this part, what happened? The metal plate here, okay, will be negatively charged. Okay, when it is negatively charged, so the electron, this is metal plate negatively charged. So there is a repulsion force. Okay, so they repel each other. But some of the energetic electron still manage to reach the metal plate here, even though this is negatively charged. Okay, but that's why there is still reading here. But when we varies the voltage across the two plates here, okay, by increasing the voltage across the the two metal plates, so the higher the voltage will decrease the flow of current. So even the energetic photoelectrons, okay, until the energetic photoelectron cannot reach the metal plate here. Okay, so this is where the voltage here will show zero reading. Okay, zero reading. No, sorry, the voltage here will show negative, let's say negative 0.1, 0.5 reading for the graph here, and the emitter show zeros reading. Okay, so the electron no longer can reach here at certain value of V. So we call this voltage as stopping potential. The symbol we use is Vs. Okay, this is about the graph. So you need to understand how the graph, we get the graph I against V. Okay, so after you understand that, so now we go to the first question. Okay, so the first question. The cathode is illuminated by a monochromatic light of frequency F. So F is given. Okay, we are going to find Kmax. Kmax, kinetic energy, maximum kinetic energy. So what is the relationship between maximum kinetic energy and stopping potential? Okay, this one comes from the formula. Maximum kinetic energy is given by the QV. Okay, so the Q, the charge is electron, and the V is the stopping potential. Okay, so this is the kinetic energy maximum. This equation comes from the principle of conservation of energy. Okay, so now we can substitute the value of electron, which is 1.6 times 10 to the power of negative 19, and the stopping potential from the graph is 1.5. So the kinetic energy is 2.4 times 10 to the power of negative 19 joule. Okay, so those who have done, did you get the same answer as me or not? So if you are there, you can just write there like yes or whatever to show that you are here with me. Okay, so now we go to next up question. Okay, we put this Kmax answer to this question side at the right side. Okay, now question 2. Okay, question 2. If the work function of the cathode is 1.02 electron volt, so determine the frequency F of the light used. Okay, so frequency of the light given as F, we use symbol F. The work function is 1.02 electron volt. So what is the equation you are going to use here, formula? Okay, can you remember the photoelectric effect question? Okay, Einstein photoelectric. So the formula of Einstein photoelectric effect, okay, is HF equals to Kmax plus work function. Okay, HF is the energy of the photon. Okay, E equals to HF, and H is Planck constant. Okay, F is what we are going to determine, the frequency. So W is work function, so given. And Kmax, we have done in question 1. Okay, so you only need to memorize the Einstein photoelectric equation, which also comes from the principle of conservation of energy. Okay, so the left side is the energy of the photon, and the left side is energy received by the electron in the metal. Okay. Okay, so now we substitute the Planck constant, which is 6.63 times 10 to the power of negative 34. Okay, the frequency, the Kmax, maximum kinetic energy from the first question, and the work function. Okay, this one you must be very careful. The work function unit is electron volt, whereas the maximum kinetic energy just now is in unit, joule unit. So you need to convert the 1.02 electron volt to joule. So how to convert the 1.02 electron volt to joule? So you multiply by 1.6 times 10 to the power of negative 19. Okay, so you must know how to convert electron volt to joule and joule to electron volt. Okay, so the terms used here, if all in joules, if must all have same unit joule. If one is electron volt, so all must convert to electron volt unit. Okay, that's the how to use this equation. Okay, so in this case 1.02 is in electron volt, so you must convert it to joule. Okay, so now we can solve for frequency. So the frequency is 6.08 times 10 to the power of 14 Hertz. Okay, so that's the answer. So we keep this value on the right side of the question. Okay, sub-question. Then we go to, we solve sub-question 3. Okay, for sub-question 3, okay, let's read the question. If only 20% of the incident photons emits photoelectrons, so determine the power of the incident light. Okay, determine the power of the incident light. So be careful here, only 20% of the incident photons emit photoelectron. So not all, not all photons incident to the metal plates emits photoelectrons, only 20%. So you need to determine the number of these photoelectrons first, photoelectrons. Okay, so determine the power. Okay, how is power relate with the number of photons? Okay, number of photons. So the power is power of the incident light. So from the formula, power equals to energy per time. Okay, this is formula you've learned in your secondary school, form 4, form 5. So power is energy per time. So the energy here is energy from the photon, energy of the photon incident to the metal plate, which is HF. So there are NP number of photon. So you times the NP. So we are going to find this NP. But the given here is 20% of photons emits photoelectron. So we need to get the number of photoelectron first. Okay, then we can find the number of photons. Okay, so in that case, we need another clue is, you see from question 1 and 2, we haven't used this value yet. Okay, 8 microampere. So the next question is something to do with this current. And then what is current actually? So current is the rate of flow of charge, which is electron. So that's mean it must this question must something to do with the charge, and the charge is n times electron. So 1 electron, the charge is 1.6 times 10 to the power of negative 19 coulomb. So there are n number of electron. So n number of electron times the charge of electron, so you can get the charge. Okay, so to relate with current, okay, from form 4, form 5, you also learn Q equals to IT. So the current is Q per T. Okay, so this is where the 8 microampere here can be related to the Q in the formula here. So Q per T is I. So Q per T is I and equals to NE per T. So you can get N number of electrons here. Okay, so this is number of electrons, not number of photons yet. So number of electrons, okay, flow per second. Okay, so we rearrange the equation here. N per T equals to I per E. So cross multiply here. So I per E. So the current here is 8.0 microampere. So you substitute the 8, convert to ampere. So 8 times 10 to the power of negative 6. And then the electron charge is 1.6 times 10 to the power of negative 19. So we get the number of electrons flow per second. Okay, so this one is in 1 second. So per second. So this is number of electron per second. So number of electron flow per second is only 20%, given by the question here. This is 20%. And the number of photon correspond to this. Okay, correspond to this. So this means 20%, okay, incident photons emits this number of photoelectrons. So 20% photons emit this number of photoelectrons. Okay. So therefore, if hundreds of photons, so actually how many photoelectrons? So which is equals to the number of photons for the incident light. Okay, number of photons in the incident light. So 100%, how many? So we use a ratio method. Okay, hopefully you can understand. So we use ratio. So 20, this is number of photons emitted per second, because the 5 times 13 is per second. Okay, so we use ratio 20 per 100 and then 5 times 10 to the power of 13 per NP. So that's mean cross multiply, we get NP 2.5 times 10 to the power of 14. Okay, so this is the 100% of photons supposed to emit this number of photoelectrons, but only 20%, okay, emits. Okay, so this is for full power of the incident light. Okay, so now we can substitute this for per second unit. So because this is NP per T, so you substitute this value into here, NP per T, and then substitute the H Planck constant and the frequency from question 2 we've done. Okay, then the answer is 1.01 times 10 to the power of negative 4 watt. Okay, so actually it's very simple. So you just really need to understand the graph, okay, and then what the questions want. Okay, so the question said and only 20% of the incident photons. So for the power of the incident light, we need to calculate the 100%. Okay, so this is the answer. Anyone who get the same answer with me can write there in the chat box. Okay, so looks like no one get same answer with me, but I hope you all can understand how we get the answer. 1.01 times 10 to the power of negative 4 watt. Okay, so now we go to question 2. Okay, question 2. Okay, we read the question together. Okay, the energy of the electron in a hydrogen atom is given by the equation, okay, E n, this is energy level n, okay, level 1, 2, 3, ... Okay, given by negative 13.6 per n squared, unit is electron volt. So calculate the energy of the electron in the ground state. So this means N1, ground state, it is understood that it is N1. But the question asks you to answer in unit, joule unit, in joule unit. Okay, so another question is an electron in the hydrogen atom makes a transition from energy level N5 to energy level N2 and emits a photon. So find the energy emitted by the atom in electron volt, determine the wavelength of the emitted photon, and state the series in which the line spectra due to the photon is located. Okay, so we do question A first. Okay, ground state means that n equals to 1. So n is 1. We are going to find E1. Okay, so using the formula given, okay, 13.6 per n squared. So the n here is 1. Okay, so it's negative 13.6 electron volt. But be careful, the questions ask you to write in joule unit. So you need to multiply by 1.6 times 10 to the power of negative 19 so that you get the unit in joule. So it's negative 2.18 times 10 to the power of negative 18 joule. Okay, very simple the question. So this question you are lucky you are given the formula already. Okay, so now we go to the next question. So we put this here. Now we go to question B. Okay, so we are going to find the energy emitted by the atom. Okay, this time the question asks you to write in electron volt unit. Okay, so for question B, okay, energy emitted by the atom is equals to the change in energy, which is E5 minus E2. Okay, for the energy emitted by the atom. So E5 minus E2. Okay, using this formula, so 5 means N5, 2 means N2. So you get 2.856 electron volt. So I purposely write this in 4 significant figures so that to be used in the next question. You can write in 3 significant figures. Okay, to find the, okay, we put this on the right side of the sub question. Okay, now for question C, determine the wavelength of the energy for emitted photon. Okay, so the wavelength of the emitted photon, we use E equals to HF. Okay, so the E just now is 2.856 electron volts. So do you realize that I haven't put, I didn't round up to 2.86 because before you come to the final result, so don't round off too early. So that's why I write the energy emitted just now in question B to 4 significant figures. Okay, 2.856 equals to H. F is c per lambda. C is speed of light. Okay, so now substitute the Planck constant, and c is speed of light 3.0 times 10 to the power of 8, and the lambda is what we are going to find. Okay, cross multiply, so we get the wavelength equals to 4.35 times 10 to the power of negative 7 meter. So all is SI unit. So the answer is 4.37 times 10 to the power of negative 7 meter. So the electron volt here, okay, convert to joule. Okay, so because HF is in joule. Okay, so to convert to joule, so you divide by 1.6 times 10 to the power of negative 19. So I didn't put here, I didn't convert it yet. I didn't put here. So you convert to joule because HF is in joule. Meter is an SI unit. So electron volt, so you need to convert to joule. Okay, which I didn't show here. So remember that you need to know how to convert a joule unit to electron volt and electron volt to joule unit. Okay, so check the answer. The answer is supposed to be 4.35 times 10 to the power of negative 7 meter. Okay, so now we put here on the right side of the question. And lastly, question D. State the series in which the line spectra due to photon is located. Okay, for the line spectra, okay, the series you've learned in your level, for STPM level, you've learned 3 series, 3 series, which is Lyman series, Balmer series and Passion series. Okay, so Lyman series usually is a UV. Then Balmer series partly visible and partly is the non-visible light, which is the mix of light, visible and non-visible light. And Passion series is the area of infrared light. Okay, so you must know this. Okay, so for the what we get, okay, the series you get is the difference, where you get this series is from the difference of the energy level. Okay, like the Lyman series is between the excited electron to reach the N1 energy level. So where Balmer series is when excited electron reach the N2 energy level. Whereas for Passion series, okay, the energy excited electron reach the N1 level, N3, okay, N3 level. Okay, so now 4.35 times 10 to the power of negative 7. Okay, you convert to a nanometer. So it's about 435 nanometer. So it lies somewhere here, between 300 and 600 nanometer. So this means the answer for D, okay, the series which the spectra, line spectra, is in Balmer series. Okay, the answer is Balmer series. 435 lies somewhere here. So it's in the Balmer series. The line spectra is the Balmer series. So you need to memorize this also. Okay, there is a lot of series, but in your level, we just to memorize these three series. Okay, so now we finish two questions. Okay, so we take a rest first for advertisement. So 1 minute rest. So I will okay, before we take a break, okay, I will announce the third digit code. Okay, so the third digit code is number 8. Okay, the third digit code is number 8. Okay, number 8. Okay, so we rest for the iklan for a while.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, welcome back everyone. So before we continue, I will announce the fourth digit code. Okay, so for the credit claim, the code is number 3. Okay, the code is number 3. Okay, so we continue with the question 3. Okay, continue with question 3. Okay, we read the question together. And those who have done, you can write there in the chat box. Okay, a radioactive point source of decay constant 6.0 times 10 to the power of negative 11 per second decays by emitting beta particles with the same probability in all directions. So the number of beta particles detected in an area of 2.0 centimeters squared at a distance of 10 centimeter from the radioactive source is 1000 per second. So by assuming that each of the nucleus in the radioactive point source decays to form a stable nucleus, so determine the number of radioactive nucleus in the point source. Okay, question 2, the fraction of the radioactive source that remains after 50 years. And question 3, the activity for the radioactive source after after 50 years. Okay, so how to solve this question? Okay, looks like no one write in the chat box. Okay, do you know or not the answer? Okay, so let's discuss together. Okay, question 1. So, do you all understand the question or not? So you must understand the question. So first step, determine what is given in the question. So you are given wavelength, okay, which is 6.0 times 10 to the power of negative 11 per second. So this one is not a wavelength. This one is the decay constant, which we use symbol lambda also. Okay, so that don't get confused with the symbol. So some books use K symbol, but our books we refer to is using lambda as a decay constant. Okay, so this one is not wavelength. This one is decay constant, which use symbol lambda. Okay, decay constant is given. Okay, then area is given. Okay, this is at 10 centimeter radius. Okay, because this is point source, so that means it form a sphere from the point source. So this one 10 centimeter is the radius where the point source emits 100 per second at the area given. But the area is only about 2 centimeters squared. So can you all imagine this or not? Okay, if you all cannot imagine, okay, I help you to understand what's the questions means here. So you must be able to imagine this. We are going to find the number of nucleus in the point source. Okay, so from the end rate, this is a rate, okay, 100 per second. So this is dn by dt. So by labeling like this, so it is understood here that a formula to be used is dn by dt equals to negative lambda n. Okay, so decay constant times n, number of nucleus produced, number of radioactive nucleus. Not yet decay, n. So dn by dt. Okay, so cross multiply here, you get dn by dt per lambda. Okay, so we are going to find dn by dt. So decay constant is given. Okay, so dn by dt here is only for this area, 2 centimeters squared. But what about the whole area? What you call it? The spherical surface. It forms a spherical surface for the point source. Okay, I help you all to imagine by this diagram. Okay, this is the point source. Point source. Okay, so at distance r centimeter here, okay, the area covered 2 centimeters squared produce this 100 per second. Okay, dn by dt. This is what is meant by the question. Okay, you can imagine like this. Okay, I help you by this drawing. So hopefully you can imagine. So what about the whole area, which is a spherical surface? You should know the formula is 4 pi r squared. Okay, the whole surface is 4 pi r squared. For this surface is given 1000 per second. Okay, the n for 1 second, this is the n number. And the distance 10 centimeter. Okay, to find the n by dt for the whole surface area, so you can use ratio method. Okay, very simple. You can use ratio method. So 2 centimeters squared give you 1000, okay, n per second. So for 4 pi r squared, so what is the n, okay, per second? So that means this is dn by dt per second. So you use ratio 2 per 4 pi r squared equals to 1000 per dn by dt. So this is dn by dt that we are going to get from the point source here. So you cross multiply here, so you get 1000 times 4 pi r squared per 2. Okay, per 2 centimeter squared. Centimeter also in centimeter, the r is centimeter, so centimeter squared and centimeter squared cancel out. That's why we didn't convert this centimeter squared because cancel out from here already the unit. So you must be able to understand this. or if you are afraid to make maybe a careless mistake for the unit, so better you convert all the unit to SI unit. But actually here we don't need to convert to SI unit because the centimeter squared here cancel the centimeter squared from the area here. Okay, so now the answer, the n by dt is 6.28 times 10 to the power 5 per second. So you can substitute into the equation now to get the n number of radioactive nucleus in the point source. Okay. So the answer is 1.05 times 10 to the power of 16 atoms. Okay, so now done for question 1. So we put here at the right side of the sub-question because we are going to use this later in the next sub-question. Okay, so we go to the next slide. Okay, if you don't have enough time to copy, it's okay. You can refer back to this video later. Okay, so now we go to question 2. Okay, question 2. What is the fraction of the radioactive source that remains after 50 years? So now the time is 50 years to the future, 50 years. So the fraction, what is meant by fraction here? So be careful, the question's one fraction. Fractions mean n per anode. Okay, so I repeat, what is fraction? Fraction is n per anode. So the fraction usually we per the original number. So the original number of the radioactive source, radioactive nucleus is anode. So n per anode. Okay, so n per anode, we are going to find. So that means we can use n equals to anode e to the power of negative lambda t. Okay, the formula, you also must know how to derive this formula, but I'm not going to discuss detail for that. You can refer to by yourself how we derive this equation. So I straight to the formula, the equation. So n equals to anode e to the power of negative lambda t. So lambda is given, time taken also given, 50 years. So the anode we bring to the right side, therefore the n per anode is equals to the e to the power of negative lambda t. Okay, very simple actually the question. You just need to understand what is fraction meant. Right? So fraction mean n per anode. Okay, so now you substitute the lambda t. So don't forget to convert the years to second. So 1 year is 365 days, and then 1 day is 24 hours, and then 1 hour is 60 minutes, and 1 minute is 60 seconds. So convert to second. Okay, 50 years convert to second and multiplied by the decay constant. So you get the answer 9.46 times 10 to the power of negative 2. Okay, so you substitute into here, and the e to the power of negative 9.46 times 10 to the power of negative 2. So this is epsilon. So you get 0.9097, the fraction. No unit because this is fraction. Fraction. So this is the answer. Okay, so I don't round it off to 3 significant features because I'm going to use this value later for the next calculation. So I keep this value in 4 significant features put at the right side of the sub-question because we are going to use this later in question 3. Okay, so hopefully you understand. So if you understand, you can write there in the chat box to understand, or if you still not understand, you can refer the video later. Okay, so now we go to question 3. The question 3, the activity, the questions 1, the activity of the radioactive source after 50 years. So the activity means dn by dt, dn by dt after 50 years. Okay, so we use the formula dn by dt equals to negative decay constant n, lambda n. Okay, so lambda decay constant is given, but the problems is n. So how to find the n? N in 50 years. So you use this one, but this one is the fraction, the fraction. So the fraction times the number of radioactive nucleus. Okay, this one in the point source is 1.05 times 10 to the power of 16 atoms. So the fraction from here, so we get the number of nucleus which haven't decayed yet. If you cannot get, okay, so let's form this equation. This is n per n node. So when you multiply by the n number of radioactive nucleus here, so cancel out, you get n, right? You get n. So this is n node. So n per n node times n node, you get n. So this is how you get this number n. Okay. So now you solve, you get 5.73 times 10 to the power of 5 per second. Okay. So this is the activity, or dn by dt. Okay. Which is number of number of radioactive source per dt. Okay, radioactive nucleus per time taken. Okay, next we go to question 4. Okay, question 4 already. Okay, so we read the question together. For a certain cathode material used in a photoelectric effect experiment, a stopping potential of 3.0 volt was required for the light of wavelength 300 nanometer. Then 2 volt for 400 nanometer and 1 volt for 600 nanometer. So draw the graph, Vs against F. Vs is a stopping potential, should be mentioned here. So Vs is stopping potential against the frequency, and determine the work function for this material. Okay, from the graph. Okay, it doesn't mention, but it's understood to determine the work function from the graph for this material, and the value for Planck constant, and the maximum wavelength or cut-off wavelength, for which these electrons are emitted as obtained from this data. So we are going to use the data given. So we plot the graph first. Okay, so for convenient observation, so I just plot it in the table here. So what is given in the question, I put in the table so that easy to see when you plot the graph. Okay, and then for the wavelength is, this lambda is the wavelength, 300 nanometer, 400 nanometer, and 600 nanometer for each stopping potential. Okay, so now we can plot the graph stopping potential against frequency in hertz. Okay, so the frequency is in hertz is, this one is nanometer, so be careful lah. So in hertz is become times 10 to the power of negative 15. So we find the frequency first in hertz. Okay, you use C equals to F lambda. So frequency is C per lambda. So C is the speed of light. Speed of light. Lambda is the wavelength. So wavelength is given 300 nanometer. Okay, convert to meter. Speed of light 3 times 10 to the power of 8. So the frequency is 1 times 10 to the power of 15 hertz. Okay. So you do the same for 100 nanometer. You substitute into here. Do the same formula. So you get 0.75 times 10 to the power of 15. And for this one, 600, substitute into here. You get 0.5 times 10 to the power of 15 hertz. Okay, so you get 3 sets of data, and we are going to plot it. Okay, plot it. So the scale I use is one square. Okay, unit 1 volt. 1 square unit 1 volt. 1 to 3 here. You can use graph paper provided. Okay, here I just draw straight away lah here. Okay, usually graph paper provided in the exam, or the square here is provided. Okay, so after plotting, so you and the scale of the f axis here by 0.25, 0.5. So 2 square to represent 0.5 times 10 to the 15 hertz. Okay, so now after plotting the graph, so we are going to determine the work function and Planck constant and wavelength. Okay, maximum wavelength. So what can be how we analyze the graph? Okay, how we analyze the graph, and the graph we get is a straight line graph. So to analyze it, okay, you need to know the y-intercept, what is it for, what is the gradient of the graph, what represent the gradient of the graph, or some graph, the analyzement also can be done from the area under the graph. So 3 basic analysis from the analysis from the graph can be made, from the gradient, from the y-intercept or x-intercept. Another one is from the area under the graph. And the graph is a straight line graph. So the general equation for the straight line graph is y equals to mx plus c. This one you've learned in maths. So the y is stopping potential, the x is the frequency, okay, c is y-intercept, and m is the gradient. Okay, so the graph actually, okay, the stopping potential and the frequency comes from the photoelectric effect equation. Okay, so this is the Einstein photoelectric effect equation. So we are going to discuss here how we get the graph. Okay, how we get the graph. So why the question asks you to plot stopping potential against frequency? Okay, we are going to discuss in detail for the question, because this is revision, right? Even though no marks for that. Okay, so now from the equation, from the graph here, we get from the Einstein photoelectric equation. So HF equals to work function plus the Kmax, maximum kinetic energy by the photoelectron. Okay, so another one is the stopping potential relationship between maximum kinetic energy. Okay, we have came across these two equations in the previous discussion, first slide, okay, first question. So we combine this, we get equation HF equals to work function plus EVS. HF, I repeat, is the energy of the photon. Okay, so now we rearrange the equation here so that we get in the form of y equals to mx plus c. So EVS remain on the right side, work function bring to the side become minus work function. Okay, so now we divided by E because y-axis which represent y is only Vs, for Vs. Okay, so y is only for Vs. But I put here V naught. V naught means Vs. Some books use V naught. So some books use Vs as a stopping potential. Okay, so this is stopping potential. So only Vs on for y. So E we bring to the right side. Right? So divided by E all the terms. Okay, so now we already got the equation in the form of y equals to mx plus c. Okay, so we just compare with the graph here. So Vs is y, okay, and the x, the gradient is h per e. Okay, here the m here, gradient is h per e. X is frequency, Okay, this is y-axis frequency. And the y-intercept, C is y-intercept is work function per E. So from here, you know how to calculate work function. Okay, so work function can be calculated using y-intercept. Okay, so the Planck constant can be calculated using gradient. So that is how we analyze the graph. Okay, now we go to work function because the question asks you to find work function first. So the work function is the y-intercept. So this point is 1. The stopping potential for the graph is 1. So you equate W per E here, work function per electron charge equals to 1. Okay, very simple. Just read from the graph. So this y-intercept, which is work function per E, equals to 1. Okay, so you cross multiply 1 times E. So that's mean the work function is 1.6 times 10 to the power of negative 19 joule. Okay, you also can write in it the work function in electron volt unit, but I just leave it in joule here, joule unit. Okay, so why is in joule unit? Because electron is in coulomb, charge coulomb. So coulomb is SI unit. So that's why the work function here is in joule unit. Be careful with the unit. If SI unit, so that's mean the work function is in joule unit. So it's not in the electron volt unit. Okay, so next is to find the Planck constant. So to find the Planck constant from the graph, okay, refer to the equation here. The gradient, we can calculate the Planck constant from the gradient. Okay, here H per E equals to the gradient. So gradient, choose the gradient as big as possible from the graph. Okay, M is gradient. Okay, so Planck constant is H per E equals to the gradient. So the gradient is formula, if you learn in maths, is y2 minus y1 per x2 minus x1, or vertical distance divided by horizontal distance. So vertical length divided by horizontal length, in other words. So for vertical length, here is 3 minus 3, 0 to 3, so 3 plus 1 is 4. Okay, so vertical length is 4 volt, 4, divided by the horizontal length is 1, 0 to 1, so 1. Don't forget that it's time 10 to the power of 15. So this is where student makes a careless mistake every year. They forgot that the frequency actually, the scale used is times 10 to the power of 15. So 1 from here to here is 1 times 10 to the power of 15. Okay, so you no need to put the unit because it's cancelled out here. Or at the final, then only we can put the unit. Okay, so Planck constant, cross multiply here, times E. So 4 times 10 to the power of negative 15 times E. And then divide 4. I forgot. Okay, this one divided by 10 to the power of 15, so becomes 4 times 10 to the power of 15, and then times the E, cross multiply. Okay, the rest is all maths lah. And the Planck constant, we get 6.4 times 10 to the power of negative 34 joule second. So the unit for Planck constant is joule per second. Okay, so this is the answer for Planck constant. Okay, done for Planck constant. And lastly is the maximum wavelength, or another word is a cut-off wavelength. So how we analyze the graph? Okay, remember that I said there are 3 ways for graph analysis, which is y-intercept, x-intercept, gradient of the graph, and area under the graph. So in this case, we haven't done the x-intercept. So the x-intercept will give you the threshold frequency. when the stopping potential is 0. So this is threshold frequency, which is 0.25. Don't forget, times 10 to the 15 Hertz. Okay, from the graph. Okay, threshold frequency, if you use C equals to F lambda, will give you maximum wavelength. Okay, which is cut off wavelength. So if this is F naught, threshold frequency, this is also will be lambda naught, cut off wavelength or maximum wavelength. So we can use this formula from the x-intercept of the graph, where the stopping potential becomes 0. Okay, no current flow here. Sorry, no, it's not no current flow. The stopping potential, that's mean no current means the maximum voltage across the tube, the evacuated tube just now, so that no electron managed to reach the metal plate. Okay, if you can remember what we discussed just now. Okay, so now we substitute into here. C is 3 times 10 to the power 8, and then 0.25 times 10 to the power 15. So you get 1,200 nanometer. You can convert it to use prefix unit and prefix form of the unit, nanometer. Okay. Okay, so that's the answer. Okay, so that's question 4. Next is question 5. Final answer I give you. Okay, so let's read the question together. Transition between the 3 energy levels in an atom give rise to 3 spectral lines of wavelength lambda 1, lambda 2, and lambda 3 in decreasing magnitudes. So which of the following correctly relates lambda 1, lambda 2, and lambda 3? Okay, so you are given 3 energy levels. So that's mean can be E1, E2, E3, or energy 3, any 3 levels, okay? And then you are given lambda n. Okay, so there are 3 levels here. How to imagine this? So you draw the energy levels, E1, E2, E3. Okay, so if decreasing in magnitude, so that means starting from lambda 3, the change in energy will give you E3 minus E1, the highest value, E3 minus E1 for the highest value for the wavelength, because change in energy is equals to HF, frequency is C per lambda, so they are inversely to each other. Okay, this is lambda 2. So there are 3 possible transition. There are 3 possible transition of energy. Can be E3 to E1. Okay, can be E2 to E1, and also can be E3 to E2. Okay, E3 to E2. There are only 3 possibles change in energy. Okay, so the change in energy is given by HF of the photon. Release, so the photon release. So when the transition happen, so the photon is released with this wavelength, okay, wavelength lambda 3. So this will be the maximum. So FC is C per lambda. So you can see here how the relationship between change in energy to wavelength. Okay, so when lambda decreasing, the change in energy increasing. So that's why lambda 3 will be E3 minus E1. Lambda 2 will be E2 minus E1, and lambda 1 will be E3 minus E1. Okay, so now you form the 3 equations from here. Okay, change in energy is E initial minus E final. Okay, so F is C per lambda. So you form 3 equations. For E3 to E1, your E3 to minus E1, HC per lambda 3. Okay, for E2 and E1 will be lambda 2. So E2 minus E1. And lastly is lambda 1. So E3 minus E2. E3 minus E2 will give you lambda 1. Okay, so now you use simultaneous equation to solve this, and HC can be cancelled out. So there are many methods to use simultaneous equation. So I use this method instead. So I choose E3 minus E1 because this one can be relate with the other two equation. E3 minus E1 can be put as, okay, E3 minus E1 here. So you can put in the middle minus E2 plus E2, because when you minus E2 plus E2, you see, you don't change the equation here. E3 minus E1, okay, when you put plus E2 minus E2, this one is 0, right? So you can relate with the change in energy with the other two equation. So you put bracket, you can see that E3 minus E2 is this one, Hc per lambda 1, and E2 minus E1 is Hc per lambda 2. So this is how simultaneous equation I made from these three equations. Okay, so now you substitute E3 minus E1 is Hc per lambda 3. So E3 minus E2 is Hc per lambda 1. And then E2 minus E1 is Hc per lambda 2. Okay? Or you can use other method. Many methods actually. But I use this method. It is faster to solve. Okay, so now you can cancel all the Hc because Planck constant and the speed of light is constant. And the answer become 1 per lambda 3 equals to 1 per lambda 1 plus 1 per lambda 2. Okay, so you get the answer A. Okay, the answer A. Okay, so that's all for the discussion for today. So we managed to finish all the question, the discussion for today. Okay, so with God's grace, we have reached the end of today's lesson. So congratulations to those who are able to follow the lesson from the beginning till the end. Okay, so before we end our session for today, I will announce the last digit code for credit claim. So the digit is number 6. The digit is number 6. Okay, so all of you, so please stop posting your comments for a while. But I didn't see any comments there. Okay, but it's okay. You can refer the video later. Okay, for your revision or for your more understanding of the question, the 5 questions just now. Okay, and click the subscribe button, those who haven't done, and activate the icon bell so that you will not miss the next class lesson. So then if you find that the lesson was beneficial, so click like and share to your friends on your social media. Okay, okay, I can see Kahlok Chong Kahlok Okay, thanks for with me today. Okay, and happy Hari Raya. You said thank you Kahlok. Okay, so once completed, you type down on the chat box, and before the certificate link is given as a token of thank you for your dedication in joining the free online class today. So I will put the link for the certificate and credit claim in the chat box. Okay, so wait for a while. I copy and paste it there in the chat box. Okay. Another one is the credit claim. Okay, done. And my username, okay, my username is Rosmaya 70. Okay, so the link will end half an hour after this live. So make sure to use the EDD email and more email only to log in. So incorrect email use will not be entertained. So if you have got one, please apply. You haven't got one, apply. The link to apply the EDD email already given in the chat box. So if you wish to get more information on the online classes, so you go to the www.academyyoutuber.com, and to those who haven't joined the EDD Junior Telegram, please do so. So once again, I would like to thank all of the students for joining today. You are awesome. So feel free to share this free tuition class to your friends and teachers all over Malaysia, because this is the collective effort from all the teachers throughout Malaysia. So I think that's all for now. See you in another session, okay, another lesson. So remember the hashtag bermula percuma and selamanya percuma. So Assalamualaikum. Stay safe till we meet again next week. Okay, same day. So today is Sunday, but the time is back to normal, not 3:30, back to 5 p.m. because fasting month has come to the end already. And selamat Hari Raya Puasa again, and bye-bye. Okay.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.